A gear is a wheel with evenly spaced teeth around the outer edge. When two gears are placed next to each other, their teeth mesh. Turning one gear causes the other gear to turn in the opposite direction. In this way, gears transfer force. When gears of different sizes are connected, they function like a wheel and axle to modify force. The smaller gear always moves faster than the larger gear in any gear system. The focus question for this lesson is, how are gears used to transfer force and motion? In Activity 7, students investigate how gears are used to transfer force and motion. This activity will take about 40 minutes. The vocabulary introduced in this activity is gear and teeth. From the kit, each team of 4 students will need a gear base, 3 medium-sized gears, 1 large gear, 1 small, 2 pointers, and 1 handle. Also make copies of Activity Sheet 7, Parts A and B. Students work in teams of 4 and receive 1 set of the materials. First, introduce the word gear to the students and show them a sample gear. Then ask, how are gears different from other wheels you've seen? Gears are wheels with teeth evenly spaced around the outer edge. Then ask students why there are teeth on the gears. And that is so that the gears will mesh together. Finally, ask students to share where they've seen gears before, probably on bicycles, clocks, or wind-up toys. First, you're going to want to point out the letters on the gear base. You'll notice that there are letters A through P on the gears. These are reference points that the students will be placing the gears in the holes relative to the letters. Kathy, I'd like for you to help me with this, and let's first start out how the teacher would start the lesson, and students are instructed to place 1 medium gear in hole J on the base.
Okay, this is a medium gear in hole J.
All right, and they're going to place another one in D.
Okay.
Okay, and we talk about, do the gears work, do they interact at all?
They're not doing anything.
No. Even if you add the handle, are the gears doing anything?
Okay,
the handle usually goes on the right side,
okay,
and that is the driven gear. Okay? There's no interaction. So then the teacher says, why don't you put the gear into G hole? So put the gear into G hole,
okay,
and you can see that they are interacting. We call that meshing. As the gear is turned, what do you notice, Kathy, about the other gear?
Well, it looks like it's turning in the opposite direction.
Okay. This is how we use the pointers then. What we're going to do is let you add a pointer to the other gear. Okay. Now, rotate with the driven gear, and what do you notice about the 2 gears as they mesh?
Well, again, that makes it really clear to see the direction they're moving in.
Okay.
If I turn one way, it goes the other way.
So maybe one goes clockwise and the other one goes counterclockwise.
Oh, okay, that's a good way
Okay,
to
that's a good way to, okay.
So my one with my handle is going clockwise, and my one with the pointer is going counterclockwise.
Good terms. Okay, then we're going to invite the students to add one more gear into D.
Okay.
Now let's let them predict. When the driven gear moves, the first gear is going to go in a counterclockwise direction. What do you think the third gear will go? What direction do you think it'll go in?
Well, this one traveled in an opposite direction of this one. So I'm going to predict that this one travels in the opposite direction of this one. So this one's going clockwise, counterclockwise. I think this one will go clockwise.
Okay, let's try it, but we need to have a reference point. So let's go ahead and I'll let you put those in there so that they kind of get lined up so that we can do some comparison.
Okay, so now what do you mean by lined up?
Okay, maybe these are pointing in the same direction.
Okay.
These 2 pointers, okay? At least
They
relatively.
start out the same way?
Yeah, relatively the same direction. Okay, now try it.
Okay, I'm going to go clockwise with this one. This one's going counterclockwise, and this one is traveling clockwise.
So every other gear goes in the different direction. The first and third go in the same direction. It's important students see the pattern of the direction that the gears turn. The even number of gears go in the same direction. So ask the students to predict if a 4th gear was added, what direction would that one go in? Now that students see that there is a pattern in the rotation of the gears, we're going to investigate whether or not the gears go at the same speed. So Kathy, what I'd like for you to do is take out 1 gear.
Okay.
Okay? Now, what let's do is align these 2 gears fairly well. And as you turn the gears, let's look at the apparent speed that the gears turn. Okay?
All right. Well, they look like they're going the same speed.
I believe that I can conclude that too. Okay? Now, how many teeth do those gears have? Would that have something to do with it about whether or not they go at the same speed?
Well, let's see. Looks like there's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 teeth.
There are 20 teeth. So maybe we would then see if the students can conclude that when gears of the same size, the same number of teeth rotate, they will do so at the same speed. Then we're going to ask the students to predict whether 2 different size gears would move at the same speed. So students are directed then to remove the gears. So go ahead, Kathy, and take off both of the gears.
Okay.
All right. We're going to introduce another gear, and what we're going to try to find out is if the rate the gears turn is the same, even though they're a different size. How many teeth do we have in this gear?
Okay, let's see. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30.
Okay, great. Let's go ahead and put that gear in I. Large gear will go in I, and then let's put the smaller gear, the medium-sized gear, so that it meshes with the large gear.
Okay. Do you want me to line up that line?
I think that's great. Always having a reference point is super. Okay. All right, now we need to, we have 30 teeth in this one, 20 teeth in this one. So if we put the gear handle in the large gear.
And you want me to get it as close to that reference point as possible, about in the same direction as this?
Yes,
like
that is great.
Okay.
Now, what we're going to do is we're going to move the gear 1 complete rotation. I'll rotate this gear, and you count the rotations on the smaller gear.
Okay, so every time it comes back to this point, I'm going to count 1.
Yes,
okay.
All right. Ready?
Mm-hmm. Okay, it went 1 time and about not quite a half on the other.
Okay, I probably would if I'd straightened it out. All right, so we have 30 teeth here and 20 teeth here, but when this makes 1 complete rotation, the large gear makes 1 complete rotation, the smaller gear moves
faster. It has to
faster, and it goes 1.5 times around. Okay. Now what you will ask the students to do is to switch the handle on the pointer.
Okay.
We're going to count the rotations again. If the small gear goes 1.5 rotations, to the compared to the larger gear, okay, if we turn the medium-sized gear one rotation, then how many or what part of a rotation will the large gear go? Okay?
Okay.
Ready?
Okay.
One complete rotation.
Okay.
All right. What we see is that when the 20 teeth gear goes one complete rotation, then the larger gear goes only 2/3 rotation. So we have a ratio of 1 turn to 2/3 on the large gear. What would happen if we added a third gear, a smaller gear? First of all, let's count the number of teeth on the smaller gear.
Let's see, 2, 4, 6, 8, 10 teeth.
10 teeth, okay? So let's put that in M.
Okay. Okay. Is there any certain way I should line that up?
Well, I'll tell you that on this gear, there's a little raised place. And because it's always good to have a reference point, I suggest that the teachers just make a little mark there. The reason that we want to put a mark there is that if we were to put the handles or the pointers in, then it might interact and stop the smaller gear from moving.
Okay, so where should that point?
Okay.
Where should that little gear arrow point?
There we go.
Like that?
Okay, maybe we could get them all going in the same direction. So,
okay. So line up our arrow handle and this?
Yes.
Okay.
Okay.
All right, so I'll move this. And it looks like they're all pointing in the same direction. Okay.
Okay. Now, we know that the third gear is going to go, these will go in opposite direction, and the third one will go in the same direction as the first and third will go in the same direction, okay? So what we want to do now is count the number of rotations that the small gear makes to one rotation of the medium-sized gear.
Okay.
Okay?
That's 1 and 2.
2. So with 10 teeth, this one goes around twice as many times as the one with 20. When this one only goes around, the large gear only goes around 2/3 when the medium gear makes one rotation. Now that students conclude that the smaller the gear is, the faster it turns, they can go to their activity sheets where they will make predictions, then gather data to support what they've learned in this lesson. For cleanup, simply collect the gears, bases, handles, and pointers and just return them to the kits.